Welcome to Frost & Sullivan's Growth Podcast series. This edition breaks down highlights from our Frost Radar analysis, evaluating market leaders, innovation benchmarks, and growth potential across STEM. Competing at the edge, benchmarking innovators, transforming real-time AI. We'll spotlight companies to action and explore what separates emerging leaders from the rest of the field. Artificial intelligence is no longer confined to centralized data centers. It's moving closer to where data is created, inside machines, vehicles, factories, and connected infrastructure. As industries adopt autonomous systems, robotics, smart devices, and real-time analytics, one requirement is becoming non-negotiable. AI must operate where decisions are made. This shift is driving rapid adoption of edge AI accelerators, specialized processors designed to run neural network inference directly on device. According to Frost & Sullivan's latest analysis, Frost Radar Edge AI Accelerators 2025, this market is entering a pivotal growth phase, reshaping how intelligence is deployed, scaled, and monetized across industries.
So what's accelerating this move toward edge AI? First, latency. Cloud-based inference simply can't keep up with real-time systems. Robotics, safety platforms, and autonomous machines require decisions in milliseconds, pushing AI directly onto devices. Second, privacy and data sovereignty. Regulatory pressure and rising data risk are forcing organizations to process sensitive information locally. Edge AI enables secure on-device inference without exposing data to the cloud. Third, power efficiency. As IoT nodes and sensors proliferate, devices operating under tight energy budgets need low-power AI compute that can scale sustainably. And finally, workload diversity. Vision, audio, NLP, generative AI, and sensor fusion are now running at the edge, workloads once limited to hyperscale data centers. Together, these forces are making edge AI not just an optimization, but a strategic necessity.
Frost & Sullivan's Frost Radar Edge AI Accelerators 2025 provides a clear view into how this fast-moving landscape is evolving. The analysis benchmarks 10 standout innovators among more than 50 global companies, evaluating not just performance, but scalability, ecosystem readiness, and commercial maturity. It highlights emerging innovation pathways, from analog compute and compute-in-memory designs to RISC-V architectures and multimodal acceleration, while also identifying common barriers to scale, including ecosystem fragmentation and go-to-market complexity. For leaders in microelectronics and AI hardware, this benchmarking offers a valuable lens into where competitive advantage is truly forming.
So how are leading companies standing out in this crowded space? One major theme is hardware, software co-design. Vendors are tightly integrating silicon with SDKs, compilers, and runtimes, dramatically reducing deployment friction and accelerating time to value. Another trend is the rise of analog and compute-in-memory architectures, which minimize data movement and power consumption by processing directly within memory arrays. We're also seeing momentum around modular, scalable form factors like M.2 modules, PCIe cards, and embedded boards that allow customers to move seamlessly from prototyping to production. And finally, developer ecosystems are becoming a key battleground. Rich documentation, model libraries, and reference designs are now as important as raw performance.
Edge AI accelerators are unlocking significant growth across multiple verticals, but two stand out. First, industrial automation, robotics, and logistics. Demand for sub-10-watt, high-throughput inference is surging across robots, autonomous guided vehicles, and inspection systems. Second, automotive perception and sensor fusion. As ADAS and autonomous platforms evolve, accelerators optimized for vision, multimodal fusion, and safety-critical decision-making represent multi-billion-dollar opportunities. These use cases are shaping design priorities and separating generalized solutions from application-specific leaders.
Looking ahead, success in edge AI will require more than faster chips. Leaders will need to evolve from isolated silicon offerings to software-rich, ecosystem-driven, and application-specific platforms. That means rethinking how developer experience influences adoption, how partner ecosystems accelerate commercialization, how IP, architecture, and software integration create defensible advantage, and how modular silicon targets high-volume, real-world use cases. This is where Frost & Sullivan's competitive benchmarking framework brings clarity, helping AI hardware and microelectronics strategists understand what truly drives innovation, scalability, and commercial success in the Edge AI era. Thanks for joining us on Frost & Sullivan's Growth Podcast. For access to our research, competitive benchmarking, and best practice frameworks, head over to frost.com or email hello@frost.com. We'll be back soon with more to help you stay clear-headed and growth-ready.